do something with food coloring. Not necessarily the most practical thing, but it seems to be the most fun. And it's called adding some color. So my first question that I was going to ask, did a different colored dye have an effect on the time that it takes to disperse throughout water, to completely change the color without any outside agitation whatsoever? I did have two questions. So the next question is going to be dealing with various liquids. Does the various liquids have an effect on the time it takes to disperse as well? For this part of the experiment, I did only use one color, which is red, and then I used the 4 different liquids. Since it was in 2 parts, I'm going to go all the way through the first part, conclusions and all, and then I'm going to do the second one. So for my procedure for the first part, I poured 50 milliliters of water into a small, shallow bowl. And I did that for 4 different bowls because there's 4 different food colorings that I'm using. There's blue, green, yellow, and red. And I dispensed 5 drops of one color into each of the bowls. And then I observed what would happen, and I wrote down any data. I used a stopwatch to time it. And I have a video later on that will explain this a little bit better because you might be thinking, you know, how am I going to know whenever it's dispersed all the way? But whenever you put food coloring in something, there's a bunch of really dark swirls. And whenever the really dark swirls went away and it was all one universal color, that's when I considered it spread. And so basically, I'm like, what is happening here? That's the end result after I did it with the red color. These are the times that it took in seconds. I did 10 trials for each of the colors. The average time for the red was 282 seconds about, which is about 4 minutes and 22 seconds, which is a lot longer than I thought it was going to be. And if you watch the video, you'll kind of think after about 2 minutes it looks like it's all the way through. But I would hold it up to the light. Well, I didn't want to touch it, so I put it on the end of the table and did this weird thing. But whenever you look to the top of it, there were still the swirls there because the color would all settle at the bottom and then it would rise kind of to the top. So that's the way that I determined it. And so there wasn't a lot of variance for the red. It was all pretty much about 4 minutes and 22 seconds. The yellow was a lot shorter, which surprised me because my null hypothesis, which I neglected to mention, is that there is no difference between the color used and the amount of time that it takes. But the yellow only took 2 minutes and 51 seconds, which I thought that I did it wrong. So I actually did about 12 trials on this one because I didn't expect that to happen. But generally pretty much about 171 seconds for the yellow to spread all the way through the water. The blue is next. This is my finished product. And this one took a really, really long time, about 5.5 minutes on average. There was a really wide range of times that I got. I got 297 seconds, 364. That one I was a little weary about, but I think it ended up okay. Did the best I could. All the swirls were gone on all of them. And then finally the green took about 5 minutes and 21 seconds as well. There wasn't as much variance as the blue, although the times were similar, which the times were still really, really long, which is not what I was expecting either. And again, I only did 10 trials for the green. So for the average times, whenever we look at them all together, the green and the blue is pretty close together. The yellow was really, really short, and the red was in the middle. But to test to see if there was any statistical difference, I did some t-tests. I had to do 6 of them to make sure I covered all the bases. And the results surprised me because, I mean, from red versus blue, red versus yellow, and red versus green, they all showed a significant difference, which immediately says that I can reject my null hypothesis in those cases. And these are all really, really, really small numbers. I had to use scientific notation because I don't want to put that many zeros on a slide. So for those first 3 cases, we do reject the null. And then for the second 3, yellow versus blue and green versus yellow, there was also significant difference there as well. But for the green versus blue, that seemed to be the only one where there was no actual significant difference. And do y'all want to see the Excel file? Because I can pull it up. It has all my beautiful work in it from my statistical analysis. You do? She says yes. I hope this works. I tried Dropbox. Did it today. Okay, yeah, it's trustworthy. Please be trustworthy.
Oh, look here.
Okay, bigger. Oh, okay. Oh, please don't do that. That makes me laugh.
Go to the top of the view.
Sorry, I'm on a Mac. I mean, I'm on a PC.
Zoom. Zoom. Now choose a bigger percent.
like 125.
More.
Or 200?
However that
Is that, can everybody read that?
No.
Yeah.
Make it a little bit bigger.
I got
You
you.
can do eyes.
200.
You can put in a custom one down there. Why don't you type something in?
Okay.
2,000.
150 maybe? There we
Oh.
go. We're getting there.
Wait, that's like
I don't know what you typed.
I typed in 175. Okay.
That works.
Just as a little precursor, at work I deal with Excel files a lot, so I was really excited because before I actually did my experiment, I set up this entire file to where whenever I put in the times, everything else would fill itself in for me, and I was really excited about that. But I just had each table for each of the different colors, and I put in the times. I have the average for that specific one, median, there wasn't really a mode, so I don't know why I put that in there, the standard deviation and the variance. In this box down here, that's where I ran the actual t-tests. If you look, the formulas in here say the t-tests are not, actually say, but this is the p-value that you get. And just to test it again, which I didn't know that you could do this, but apparently I didn't have to do all the everything that I just did. How do you view tabs that I hid?
You mean experiment part?
Click on the bottom.
Go.
No, there's some that I hid.
Oh.
Do y'all know how to do that in Mac?
Not in
How
Mac.
would you
Hey, it would
unhide?
have a-
What?
It could be view or
Would
edit.
you
buttons.
unhide? Is there an unhide?
Try to edit.
Edit. Not repeat hide. Well, anyway, you can actually select your data and you can just tell it to do a statistical analysis t-test, and it pops out this whole, like Lindsay had a big table with a bunch of values that you don't really understand. But whenever I compared what I got with what the actual test got, they were the same. So I checked it twice to make sure I didn't do anything incorrect. And so this is the chart that I used for the first part of the experiment. Are there any questions over this testing?
Just click the PowerPoint button.
Okay. So the conclusion for the first part, there were 6 cases, and out of the 6 of them, we can reject not 1, but 5 of them, which means that that only leaves 1 as a failed to reject, which that surprised me because I really honestly thought that there would be no difference in any of them. So this is about the second part of my experiment, and again I poured 50 milliliters of liquid, but this time there are different liquids, because now I'm testing the time it takes for one color to spread throughout the 4 different liquids. So again, I had 4 clear bowls, and I put water, white vinegar, vegetable oil, and Sprite in the different 4 bowls. And I used 5 drops of red coloring, which that's blue, so disregard that. I used 5 drops of red coloring and put it in each of the liquids to see how that would disperse. And I have videos for these, but they're time-lapsed, so I'm going to kind of talk over them because there's no sound. So the first test that I did was water. I slowed down the beginning part of it so that you all could see how it started, how it fell to the bottom. There's swirls everywhere. This is the kind of thing that I was looking for whenever I was making my observations. I'd write this down to see if there's going to be any difference between how it disperses as well. I didn't actually test that, but that was just one of the observations I thought would be neat. So as you can see still, there's spaces around, so the color is not all the way done. I think now I sped the video up to like 4 times, but the actual time of this video before I sped it up was about 4.5 minutes. So I didn't want y'all to sit here and watch color spread for 4.5 minutes. So I tried to speed it up a little bit. But see, I tried to get it from the angle that I was looking, and you can see that around the top, it's still not colored all the way. And so now it's going really fast. And I'm sorry, there was an earthquake whenever I took this video. But see, and that's my mom bringing in pizza. I was like, don't set it on the table. She's like, what? And I was like, don't set it on the table. But see, if you look now, it's pretty much red. There's no signs that you can see through the food coloring at the top. And so that's whenever I considered the red all the way through the water. And again, that actual time was 4.5 minutes, about. The next one that I did was the white vinegar, which turned out to be a lot the same as the water. I kind of figured that it would be because they have the same consistency, they look the same. So this is actually sped up again. Again, you can see the swirls. The observations that I made mostly about this one was that it basically did almost the exact same thing as water. It took about the same amount of time, 4.5 minutes. I really wanted to look at it from different angles so that you all could appreciate the fact that it's actually spreading throughout everywhere. And again, there's still, you can see through it a little bit. And by the time it gets to the end, it's going to look exactly like the water did. Do y'all want to watch the whole thing? I think it's almost done. So again, that was about 4.5 minutes, which is about the same as the water was. Okay, next was the vegetable oil. That was not what I thought was going to happen. I really thought it was just going to kind of spread like everything else. I waited a little bit to see if eventually, you know, it was like, okay, we don't want to say balls anymore, and then it spreads. But it didn't do that. And so then I was like, well, I might as well just go ahead and see if I can put more in and make it spread. I thought maybe if they would hit each other, they would kind of, you know, like combine and then expand. It gets worse.
It's like a rabbit turd.
It was really weird to watch. I was like, there's no way that these are just going to stay balls whenever I keep putting more in there.
Did you speed this up when the
This part is slowed down.
You're crazy there.
I went a little overboard. You know, I figured I had 2 bottles of red food coloring. I might as well make the best of it. But still, I mean, the farthest that it got in dispersing was some of the color was on top, but the rest of the color was on the bottom. And
Looks red to me from there.
it's still in those cool little ball shapes. And I tried to move it, but it did not go anywhere. And then the last one is the Sprite. This one's pretty neat. If you watch it for a second, you'll see all the food color goes back up to the top, which is something I hadn't seen yet in all the other experiments besides vegetable oil. All the food color went to the bottom. But if you watch where the bubbles come up and they pop, it'll push some more of the food coloring down. So basically for the Sprite, I had to wait for the majority of the bubbles to pop before the liquid would actually go down. And this one took about 5 minutes and 20 seconds. So this one was by far the longest one that besides the vegetable oil, the longest one that took, and I thought this one was the coolest. I mean, the vegetable oil was neat, but I like to watch it. The bubbles come up and then it was just like a food coloring. So it did take a while. This is sped up. It doesn't look like it, but I promise it is. The earthquake has subsided slightly. Of course, by the time I make the last video, I can actually hold a camera. Anyway, it gets to the end, and finally, after 5.5 minutes, it's pretty red all the way throughout. It was a bit, I said it was red throughout, but there were still a few bubbles left on the bottom, which you can't have the red inside the bubble. So technically, it wasn't all the way through, but it was good enough to go. I think I would have had to sit there for a long, long, long time. So, all in all, for the water, these are the times that I got. I did this part of the experiment 10 times as well. The average was about 268 seconds, which is about the time of the video that I took. There wasn't very much variation throughout the water. For the white vinegar, the average was 257 seconds. Again, these were all the times in seconds. I did 10 trials. For the vegetable oil, it was a fail. There was no average time because it wouldn't have done anything, so I have no pretty chart for that one. And for the Sprite, the average was about 368 seconds. This had the least variance in it, which I was pretty impressed because it took a long, long time. But if you compare them statistically, again, I did t-tests, and I only had to do 3 this time. Between the water and the white vinegar, there wasn't any significant difference, which we could pretty much see through the videos. The times were the same, the results were the same. For the water and the Sprite, there was a significant difference, a pretty big one, 1.4 times 10 to the negative 14th, really. So that was a huge significant difference. And then this one was even worse. White vinegar and Sprite was 7.08 times 10 to the negative 17th. So I'm pretty sure that I can definitely say that there's a significant difference between those as well. And if you all would like to look at my Excel file, I have a whole separate tab for this side, if you would like to see it.
I'm good.
So all in all, the conclusion for part 2, out of the 3 cases that I did, we were able to reject the null in 2 of them and failed to reject in 1. Okay, spreading the vegetable oil. This is a video of my several failed attempts to try to get it to spread. These are all first takes, so if I get really excited, don't judge me. Okay. Play. This is like the coolest. Okay, here we go. Since I couldn't figure out how to get the dye to spread in the vegetable oil, this is going to be an experimentation video on different ways I'm going to try to figure out how to get the dye to spread. So let's put it in there first. Let's see if I try to stab it with a toothpick, what happens. I'm getting pretty angry. This is like blubber. Have you seen that movie? Oh my gosh, this is what they make him out of. Okay, so I just viciously stabbed all the little things of ink, and nothing happened. I've done some water in there for fun. As you can hear, my dog is barking because somebody came in the door. But let's see what happens when we pour water in here. Oh. Oh, cool. It turned into one big lump in the bottom. It's still like flubber. And this is the end result of the oil in the water. The oil is on top and all the ink is in the water, which is on the bottom. And nothing's moving. So that's pretty neat. This is after I poured a bunch of water in there. And it's a whole other world that's in between the water on the bottom and whatever residual blue ink and water is on the top. Little pieces of ice cubes in the oil. And in the ice cubes, the ink, it turns the ice cube that color. But other than that, all the balls are just kind of chilling, staying the same. It's pretty neat. Looks like an iceberg. So that was my experiment video. So basically, nothing really works. Nothing would mix with the oil enough to actually have the food coloring spread in the oil, spread it in the water, but that didn't really help much. Okay. Oh, do not do this. Okay. So the final conclusion of my experiment for both parts. For the first section, we were able to reject the null hypothesis in 5 of the 6 cases, which is pretty significant to me because I didn't expect that to happen. And for the second part, we were able to reject the null in 2 of the 3 cases that we had, which again, I did not expect to happen. Are there any questions? Yes, sir.
Okay, now that you saw that the food coloring didn't really disperse in oil, why do you think that was the case?
No, I'm into good at ideas. Do you have an idea?
Not supposed to be.
Yes, but I wanted to hear your idea.
Because food coloring is a lot like water, and oil and water don't mix. So oil and food coloring wouldn't mix.
Sounds pretty good to me.
I'll take it.
Jenna, would you like to elaborate, or Brittany, on that?
One of y'all please help me out. I'm not a science person.
Well, the density in oil and water are a lot differently, but the reason why it would go through the oil, if I'm correct, is because water is hydrophilic because it loves water, because it's water, and oil is hydrophobic, so it has a layer around it that will not let water to mix with it. I'm not sure, but if you add soap to the oil, I think it might have dispersed.
I'm gonna have to do that now.
I think because if you have oil on your hands and you stick your hand in your sinks, it doesn't wash off, but once you squirt a little bit of oil, I think that breaks down that lipid like bilayer and it breaks it apart and it'll let the water kind of interact with the oil. Try.
See, actually, sort of funny story. Before I did any of these, I was like, well, I don't really know what's gonna happen to vegetable oil, so just for me, I put it in the graduate and then I put it in the cup, whatever. And it did the whole ball thing. And so I was like, okay, I guess I'll go on with the rest of my experiment. So I put the water and stuff in the graduate, but whenever I poured it into the shallow bowls, it was like laced with oil. And I had to soak my graduate for like a day and a half to get all the oil out. And so the soap didn't, because I washed it with soap first, but it didn't get it out.
Maybe hot water too. Do you think? I mean, do you agree?
I think it's certain types of dishes.
I used the green one, Dawn.
If you use Dawn or Joy, it should do it.
It's sort of like the same thing, like, you know how they do the oil spills and then they're like washing out the oil ducts and stuff like that, but then also the feathers are now, like, now they can't repel water because the soap breaks down the waxy things and all these ducts are actually like freezing them.
I'll try it. I'll let you know if it works.
On one of your slides on the
when you were doing the different mediums, you said that you failed to reject one of them, it was at 0.01, and your p-level, your p-value was 0.05, but you failed to reject. Yeah, like go back to the slide, right there.
See, this is what, whenever Lindsay had hers up there and it was 0.01, in my brain I thought it was supposed to be 0.005, and then as soon as I was asking her the question I realized that it wasn't, so thank you. So, alright, cool, that just means it's even better. So they're all a significant difference. Thank you, Robert.
No problem.
We realized this on my linear algebra test today that I can't do math, because I thought 3 plus 1 is -2. That's what I wrote on there.
So math teacher.
I have 2 hands up. Yeah, 6 questions.
No, that's 10 questions.
10?
No, this actually doesn't have anything to do with this, but I'm just curious. Let's just say, and this is kind of off the cuff now.
Okay.
Let's just say you were going to try to do this as an experiment in class.
Mm-hmm.
Now that you've gone through it and see how long it takes,
Mm-hmm.
do you have any idea how you might approach this if you wanted to do this in a class?
If I wanted to do it in the class, I would put the students in groups. I would have them all do it at the same time. Like I would put them in groups of 4, and they would each be in control of first the color and then second the liquid.
Mm-hmm.
They'd all have their own stopwatches. So then total it would take at most 5.5 minutes,
Mm-hmm.
which is a long time, but I mean they can talk about it. And they'll get done at different times. So when one gets done, they can kind of talk about the other students with it. But that's to keep the time.
Sure, absolutely. And the thing that's really been impressive about all the presentations that we've heard so far, and I'm sure a lot of the others to follow, is that, you know, these are some real things you could actually do in a classroom. And so much of the stuff that's in the stats book, you're copying stuff out of the book and you're just doing raw numbers. The kids will not remember your lecture on the t-test, but they will remember the day that they sat there and watched the food coloring do it. And even if you made this an extended project and you told them, you know, go to each other's houses and do 10 trials of these, they'll be sitting there updating their Facebook pages and talking about whatever and eating pizza while they're waiting for it to disperse. And again, they won't remember your lecture, but they will remember that night that they got together at Katie's house and baked brownies while they were doing this. And that'll be the things they'll talk about at the 20-year reunion and the 30-year reunion and so forth. So that's my little public service announcement for today. That's my warm, fluffy side that so seldom comes out. I know. That's almost enough to dismiss the class right there.
I'm down with that.
Hey, let us know if you're gonna do that. I kinda wanna know.
I'll do it tonight.
And,
I'll tell you.
and have another presentation for Monday.
I'd like to have a social off this weekend. I did not get one last weekend. Isn't that sad? Are there any other questions?
For pre-service.
How long this whole thing taking off? Because this saw 4 minutes for each one.
It took me a whole day, like a whole day to do the actual experiments, and then like 3 days to make the presentation. It was sad. It took a long time.
It was worth it. I liked it.
Yeah, because I had to do 10
would
trials.
watch it again.
Please don't. I'm not going to say it. Y'all can go through it in
I
my
think
head.
it's just like kids would be